In front of us we have several molecules that can be found in the living world, and each of them has one very important thing in common. First, we can kind of go over what they are. This first one up here at the top right is what we call ATP, which stands for adenosine triphosphate. Down here in the bottom left we have propane, which you've probably heard of. It's used as a fuel source. It's often burned as a source of energy. In the top middle, we have carbon dioxide, which is readily found in the air and something that we produce when we do cellular respiration and we breathe it out. Here in the middle, we have glucose, which is a monosaccharide. It's a sugar that's used by most living things as a major source of energy. In the bottom right, we have methane, which you've probably heard of. And in the top right, we have ethanol, which is an alcohol, like drinking alcohol. Now, all of these compounds have one very important thing in common. They all have the element carbon. I'm going to leave a couple of these up here for us to look at for a minute. We're going to leave propane and methane here, but we're going to talk in this video about carbon, about what are its properties that make it so significant. You've probably heard that all life on Earth is what we call carbon-based, and there's a reason for that, and in this video we're going to see why that is. Here we have an atom of carbon, and there's some very important things we need to notice about it. The carbon atom is made up of 6 electrons, and you can see those around the nucleus, and it's made up of 6 protons and 6 neutrons. That means that carbon has an atomic mass of approximately 12 daltons, because we're adding the 6 protons and the 6 neutrons, and it has an atomic number of 6 because there are 6 protons, and also that means there's going to be 6 neutrons and 6 electrons. Now, there's a very important property that carbon has because of the number of protons and specifically electrons that it has, and it is that number of electrons that is what makes it so special. If we look here in the first orbital, what we can see is that we have 2 electrons, which is what we need to have in that first orbital. But in the second orbital, we like to have 8. 8 is kind of the magic number. And so when an element is what we might call, or what I call, happy, meaning that it's got that full octet, it's got all the electrons that it can have in that last outer orbital, it should have 8. But carbon only has 4, and that's very important. So we have 4 electrons here, and those outer electrons are what we call valence electrons, and those are the electrons that are used in covalent bonds. And it is actually the fact that carbon has 4 valence electrons that makes it so special. Now, what I've done is I've drawn here a Lewis dot structure of a carbon atom, and I did it in black because typically when we represent things in chemistry, we represent carbon as black. And I put 4 dots around the carbon because that represents the 4 valence electrons. So let's get into what that actually means. Let's look at this molecule right here, which is called methane. And what you can probably tell is that it is composed of 1 carbon, and it's composed of 4 hydrogens. So if you recall, those white structures represent hydrogen. And if we want to see what that would look like in our Lewis dot structure, it would look like this. So now everybody's happy. The hydrogens are happy because they have 2 electrons in that first shell, and the carbon is happy because it has a full octet. It's got all 8 electrons in its outer shell. And what this is designed to show us is that carbon can make 4, so we have 1, 2, 3, 4 covalent bonds with other molecules, and that's extremely important because carbon is used as kind of the backbone, if you want to think of it that way, of most what we call organic molecules. And organic molecules are compounds that have carbon in them, but they're also typically what we associate with living organisms. So now let's look at this other molecule that I have up here, propane. And propane consists of 1, 2, 3 carbons, and therefore it's going to have 8 hydrogens. So we're going to draw the Lewis structure of it. So I'm going to start out by drawing my 3 carbons that it has. And what you can see is that these 3 carbons are covalently bonded to one another, but yet each carbon, or at least the carbons on the end, still have 3 more bonds they can make. So we can go ahead and put our hydrogens in, because we're drawing propane, like so. And this carbon in the middle is going to have 2 hydrogens attached to it. So what we now have is we have a chain of carbons, and then we have hydrogens attached covalently to that chain, and that is the Lewis structure of propane. Now, the reason this is important is because carbon is going to be able to form all kinds of different molecules. And at the beginning of this video we looked at several, but there's just an untold amount of organic compounds that are going to be made, and carbon is going to be the basis for that. So let's look at one more. This is a compound called ethanol, and it is readily produced by yeast when they undergo anaerobic respiration, and it's what is drinking alcohol, so it's what's in beers and wines. And it consists of 2 carbons that are covalently bonded to one another, and one of these carbons is actually bonded to 3 hydrogens, and the other is bonded to 2 hydrogens, but it's bonded to an oxygen that itself is bonded to a hydrogen. And that is a type of functional group that we call a hydroxyl. And it's got some specific properties. So one neat thing about carbon is not only can carbon form chains with itself and with other hydrogens, which we would call a hydrocarbon. So if we just have something like carbons bonded to hydrogens, we would call that a hydrocarbon. Carbon can also bond to a plethora of functional groups like this hydroxyl, and the combinations of molecules that can be formed are pretty much endless. To form large molecules like this glucose that we see here, so we've got several carbons that are bonded to one another and that are also bonded to other functional groups, and that is the reason why carbon is the backbone of organic molecules and really the most essential element in terms of molecules that constitute life. And it is because of the 4 valence electrons that it has.